Section 2.3 is in Chapter 2 on graphs, and it's regarding lines. So hopefully this will be a lot of review for you. So we're going to go pretty quickly through it. It has a bunch of objectives, but they're all small. So the first one is to calculate and interpret the slope of a line. The second one is to graph lines given a point and the slope. Then we have find the equation of a vertical line. Use the point slope form of a line. And we'll also identify horizontal lines. Then we're going to use the slope-intercept form of a line. Find an equation of a line given 2 points. Then graph lines written in general form. Using intercepts. And then find equations of parallel lines. And find equations of perpendicular lines. Okay, so objective 1 is to calculate and interpret the slope of a line. So if the quantity represented by the y variable is increasing at a steady rate as x increases, we can draw a graph of the relationship and it will be a straight line. So lots of things follow this sort of a relationship. So as x increases by 1, y increases by a constant amount. So this is the formal definition. Let P be a point x sub 1, y sub 1, and Q be a point x sub 2, y sub 2, two distinct points. So we're talking about a point here that has coordinates x1, y1, and a point here that has coordinates x2, y2. Then the line through these 2 points, we use the letter M to represent that. And the equation of the line is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And this is a non-vertical line. So we'll address vertical lines in a moment. So this is a picture showing the rise and the run. So you've probably heard those words used of it's the rise over the run. And if we have x1 equaling x2, then L is a vertical line and the slope M of L is undefined. So if the line is vertical, we say the slope is undefined, and that's because we would be trying to divide by 0. So another way of talking about the slope is the change in y over the change in x, and we also use this triangle is the Greek capital letter delta, so delta y divided by delta x, and that quantity is called the average rate of change of y with respect to x. So in class, we'll use Desmos to illustrate what happens when the slope of a line changes. And now we have objective 2, which is graph lines given a point and the slope. And we'll work on that together in class. We're going to find the equation of a vertical line. And a vertical line always has an equation that looks like x equals a, some number, where a is the x-intercept. So we'll do this example in class. And then we have objective 4, use the point slope form of a line. And identify horizontal lines. So an equation of a non-vertical line with slope m that contains the point x1, y1 is y minus y sub 1 equals m times x minus x sub 1. And we call this the point slope form of the equation of a line. And this is actually the most useful one in calculus. So you really want to remind yourself about this one. We don't use it a lot in algebra, so sometimes people forget about it. And again, we'll do an example in class. And finding the equation of a horizontal line, well, let's see, what is the slope of a horizontal line? And it's 0, the number 0. Not undefined, not I don't know, not it doesn't have a slope. The only correct answer to what is the slope of a horizontal line is the number 0. And it helps me to remember that horizontal line has a slope of 0. So what does the equation of a horizontal line look like? Well, it's always going to look like y equals some number b, where b is the y-intercept. And again, we'll do an example together. Then objective 5 is the slope-intercept form. So point slope form, y minus y1 equals m times x minus x1. The slope intercept form is the one that people seem to remember better. That's the y equals mx plus b. So make sure you're familiar and confident with both of those. And we'll do examples in class. Find the equation of the line given 2 points. Well, the first thing you do is use the point slope form of the equation of a line after you have found the slope. So you find the slope, then use the point slope form of the equation of a line. And we'll do example in class. And then graph lines in general form. So that's yet another form. So we have point slope form, slope intercept form, and general form. It's also called standard form when it's written as ax plus by equals c, where a and b and c are real numbers, and the a and the b can't both be 0 because that would not give us the equation of a line. So this is only a good method really if A and B divide evenly into C, and we'll talk about that more in class together and do some examples. And objective 8 is finding equations of parallel lines. So hopefully you recall that two parallel lines, sorry, this is again two non-vertical lines, are parallel if and only if their slopes are equal and they have different y-intercepts. So this is actually two statements in one. It says if two non-vertical lines are parallel, then their slopes are equal and they have different y-intercepts. Then it also says, and if two non-vertical lines have equal slopes and they have different y-intercepts, then they're parallel. And let's talk about how we find out if two lines are parallel in class together. And then objective 9 is perpendicular lines. And again, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. And again, we have the if and only if statement. So this is actually two separate statements combined into one. So it says if two non-vertical lines are perpendicular, if the product of their slopes is -1, and if two non-vertical lines have slope whose product is -1, then they are perpendicular. So we'll talk more about that in class together. And if no form is specified on a problem, then the default is slope-intercept form.